we have to look two places. We need to take the overlap of the domains of the inside function and the final answer. So we've talked about some of these domains when we add, subtract, multiply. We had to say we needed the overlap of the domains of the two functions. Here we have to take the overlap, but we have to look a little bit closer. We need to look at the inside function and the final answer to get our domain. If you only look at the final answer, you will be right sometimes, but a lot of times you will be missing values. So it is dangerous to only look at the final answer. You will only get them right about half the time if you do that. So we're just going to go through a bunch of examples here. I have a ton on my notes. I'm probably not going to do all of them, but they're there if we need extra practice on any. Okay, so I'm going to bounce around a little bit, but if you have questions over them, make sure you speak up so we can do some more. So I think for these functions, I'm just going to do the first. So f of x is x squared plus 3x minus 1. G of x is 2x plus 3. So yesterday, we were just worried about composing when we were plugging in numbers for these. Here, when I ask for f composed with g, we're finding f of g of x. G of x, the inside is 2x plus 3. When I ask for f of that, you have to go to function f and replace all of your x's with a 2x plus 3. How can I simplify this? What do we need to do? FOIL. When you have that 2x plus 3 squared, just like when we had the x plus h squared, that just means you have two of them and you have to write it out and multiply. So we get 4x squared plus 6x and plus 6x, so plus 12x plus 9. Here, if we distribute the 3, we get 6x plus 9 minus 1. Combine like terms, so that's 4x squared plus 18x plus 17. So that's the composition. The domain. You look two places. The first thing that happens is you're going to take an x value and you're going to plug it in. So you have to look at this inside. Now, it's not a fraction, it's not a square root, so do I have any domain problems there? No, you can put anything in there. Then we have to look at our final answer. It's not a fraction, it's not a square root, so do I have any problems there? So what's my overall domain? Let's look at one. It doesn't come out to be negative infinity to positive infinity. let's talk about the composition first. F composed with G, so that means F of G of X. G of X is 4 over X minus 1. I have to plug that into F. So I'm replacing the X with 4 over X minus 1. Is it proper notation to leave a fraction in a fraction? No. So there are different ways of getting rid of this. We could get a common denominator and then flip and multiply. A faster trick that I use a lot, we know that in a fraction, as long as you do the same thing on top and bottom, that's legal. So on this, if I want to get rid of the fraction, we would have to multiply by So let's take top and bottom times X minus 1. So on the top, 1 times X minus 1 is just X minus 1. On the bottom, 4 over X minus 1 times X minus 1, what happens? Those cancel and I just get a 4. Plus 2 times X minus 1. What would we have to do? So that gives me a 2x minus 2. Did I lose anyone right there? Kind of did some fancy algebra and saved ourselves a whole lot of time getting rid of that fraction. So then all we have to do is add like terms. So we have x minus 1 on top and 2x plus 2 on the bottom. Okay, that's my composition. For the domain, you look 2 places. The inside, the first thing you plug in. So if I'm looking at that, what can x not equal? Because that makes the bottom 0. Then we look at our final answer. How do we find that domain? The bottom can't be 0. And you get the x can't be negative 1. Okay, so my overall domain, in general, if it's just one value x can't equal, I want you to say the interval notation. If it's more than one, the interval notation can get a little bit long, so you are welcome to just list them. If you wrote the interval notation for this, it would be everything smaller than -1, union everything between -1 and 1, union everything bigger than 1. So if it's just one value x can't equal, give me that interval. If it's more than 1, you can just say x cannot be and list those numbers. You guys think you could try one like this? Here is your problem to try. You have the f of g of x. So g is 2 over x. Plug that into f. What do we have to do here? Get that x off the bottom. So if you take everything times x, you get 3x over 2 minus x. So domain, we look 2 places. The inside. So when I'm looking at that, x can't be. And then we look at the final answer. When I'm looking at it, x can't be 2. So my final domain, you can tell me x cannot be 0 and 2. If you wrote the interval, it's negative infinity to 0, union 0 to 2, union 2 to infinity. How do we do on that one? Good? Okay, let me give you Another problem like this, before we move on, I want to throw one with some radicals in here. So this time we are going to do both F composed with G and G composed with F. So F composed with G. That is F of 3x. So you go to F and you replace that x with a 3x. So that's my composition. For my domain, if I look at the inside, when you see 3x, what's the domain of that? Do we have any problems with it? It's not a fraction, it's not a radical, so we can put anything in there. So then we need to look at this piece. It's under a square root. What do you know about something under a square root? It has to be positive, greater than or equal to 0. So 3x greater than or equal to 1. So x is greater than or equal to 1/3. So this one could have been anything. It's like saying all real numbers. And this one had to be greater than or equal to 1/3. So when you put those together, it's just you're greater than or equal to 1/3. If we go the other way, G of f of x. So f is the square root of x minus 1. We have to put that into G, so it's 3 times the square root of x minus 1. Domain. Look at your inside. So for this, you know that x minus 1 has to be greater than or equal to 0, so x has to be greater than or equal to 1. Look at the final answer. We again have a square root, so the thing underneath greater than or equal to 0, so you just still get the x is greater than or equal to 1. So your final domain would be bracket 1, comma, infinity.
Do we have questions?
Do we need more practice with any of these? And I only have one other type of problem. Well, I've got a ton of these examples, but if you guys don't need them, I won't do them all. Let's go to this kind. This says, find functions f and g such that f composed with g equals h if h of x is x squared plus 1 to the 50th. So this is telling me we get h of x by doing f of g of x. So my h of x is x squared plus 1 to the 50th. I want to know what my f and my g are. On these problems, a lot of times there's more than one correct answer. You just have to give me a possibility so that when I find f composed with g, I get this answer. What I usually do is just say, okay, g is the inside here. So what would be the inside of my final function? squared plus 1. So that's my g of x. Now think about what you do when you compose functions. We take the thing we're plugging in and we replace the x with it, right? So if I'm going backwards, if I take that thing back out, then it turns back into an x. So if I took all this green out, it's just left as an x to the 50th power. Not the only possible answer. You could have made your g of x just a plain x squared. And then f would have to be x plus 1 to the 50th. There's multiple options here. We just need something that when we compose them gives us this original problem. Okay. Let's try another one. We're saying our h is equal to f composed with g. G is your inside function, or the first thing you do. If you have 1 over x plus 1, what are you going to do first? Can we just do the bottom, x plus 1? So that would be my g. Then my outside, all you have to do is take out that x plus 1 and replace it with x. So it would be 1 over x. One more I want you guys to try on your own. So we made f composed with g to equal this. So g is your inside. So g of x is 2x plus 3, which means f, you take that out and just replace it with an x, you have an x to the 4. Alright, is all this okay? So, homework today, I made another handout for you. There is one typo on this though. Sorry, I keep trying to type these because the book problems I don't like and then I make mistakes. Okay, on question number 1, you have the 2 tables. Table 1 has an x and an f of x. The second table underneath it should be x and then g of x. So the second table of that last row is g of x.